All right, we come to our last example in this lecture, and before we look at this, I actually want to remind you of another example we did. We studied z equals x squared plus y squared before, which we called a paraboloid, or if you want, a circular paraboloid, because the cross sections are circles. And so you can see that these are somehow very similar. I've got z equals something involving x squared and y squared. The only difference is I put a negative here. Now think about the difference. When you have a plus here, then when z is 1, you get a circle. The minus here, when z is 1, I get out a hyperbola. And so this is going to be a hyperbolic paraboloid. And let me see if we can sketch this together. I have to admit, these are somewhat challenging to sketch by hand. Of all the ones that we've done, this is probably the hardest one to put the traces together and see what's going on. And so what we're going to do is we're going to go ahead and sketch traces for slicing at x, slicing at y, slicing it with z. But then we're going to be able to see the graph from just the x and the y traces, and then we'll just make sure that our z traces match up. So here we go. So let's go ahead and look at x equals 0 as our trace. That leads me to the equation z equals minus y squared. And I want to go ahead and graph this one right here with you. And so we're going to have the y-axis and the z-axis. And when x is 0, then that's the trace that we get. Let's do another trace right on that very graph. So let's do x equals 1. By the way, it wouldn't matter if you did -1 because this square is going to kill it. So this trace is, let's just do it, it's plus or minus 1. And that's going to lead me to, again, z equals now 1 minus y squared. And that's going to just be the same thing shifted up here like that. All right, and then those traces, as you increase x, the traces are just going to go higher and higher and higher. Okay. So that's one trace. Let's slice it another way. Let's fix y. And so let's just do y equals 0. Then that leads me to the equation z equals x squared. Interesting. That's opening up. And so if this is the x-axis, this is the z-axis, then it's going to look like that. Might as well do another one. Let's do y equals plus or minus 1. And again, we're going to get z is x squared minus 1. And so you take the same graph and you actually shift it down. It's supposed to be the same quadratic. They look a little different, but use your imaginations. All right, and then let's go ahead and do the traces when we fix z. So for example, z equals 0, you just get x squared equals y squared, so then you get a point, the origin. When z is 0, the graph is just the origin. But now let's do, like, for example, z equals 1. If I do z is 1, then I get the equation 1 equals x squared minus y squared. Classic, oops, my graph's a little off there. Classic hyperbola. And so let's see, this is going to open along the x direction like this, because x is positive. So this is the x-axis, the y-axis. What if I do z equals -1? Then I actually, when I solve for 1, I get 1 is y squared minus x squared. So I'll switch colors. Let's make this whole equation pink so that it's, whoop, that's not what I wanted. We want to make this equation pink so that we're color coordinated. Here we go. So then when z is -1, the trace actually looks like that. And so, like I said, figuring out how to put all of these together at once is quite hard, actually, to make the graph look decent. So let's just do these two, the x's and the y slices. Then we're going to come back and make sure that we can actually picture these as well. Although this gives you a good sense, too, what's happening. So here we go. Let's make an attempt at a 3D graph. I'm going to move this, and we'll comment on this at the end. But here we go. So three-dimensional picture. Actually, I think I'll go down to this page because we're going to need all the help we can get here. All right, so I want to just do what I can to try to graph this. So let's begin with the slice. This is x, this is y, this is z. Let's begin with the slice when x was 0. And I get this quadratic opening down, minus y squared. So when x is 0, my graph, let's do it, slide over for me. Okay, it's frozen. Here we go. My graph looks something like, and I'm going to do dotted on this side, something like that. Let's erase. Ooh, no. Okay, close enough. Up. Okay, so that's what it looks like. And then we said, hey, when you increase x, you shift that these traces up. So let's hold that though, and now let's graph y equals 0. So when y equals 0, I get z is x squared. So when y is 0, I'm in the zx plane, z is x squared. So we're opening up like this. Again, okay, and all of a sudden, I hope that you're beginning to get a sense of what this looks like. And now, let's go back to the other x traces. As you increase x, you simply shift that parabola up. And all of a sudden, you get a sense of what's happening here. You can hang those parabolas off of the other one here. And of course, they're going down the back. You can't quite see them. You come this way. And hopefully you can see this. It looks like a saddle almost. There's like this saddle picture here. We're actually going to call these saddles later in the course. And now let's see, can we see these different hyperbolas that we did as well? So let's slice it at z equals 1. Then you're going to have a hyperbola opening this way, and this is going to be in the xy plane, which is exactly what we have. And if we go to z equals -1 and you slice it down here, then it opens this way, and you can see that happening as well. That's the best I can do by hand. Let's switch to the computer. Before we do that, though, I do want to encourage you to have a good look at the table in your book that's on page 578. This is a really good table that lays out a lot of what we've been talking about, and it'll be a good reference point for you. All right, so let's switch to Mathematica and see what the Mathematica graph looks like. All right, so here is Mathematica's version of the saddle that we just tried to graph, and hopefully you get a good sense of what it looks like. We're going to talk about these a lot more later in the course, but for now, I want you to be able to come up with this graph, recognizing the equation. You've got, x squared minus y squared is z, and then also looking at those traces as well. All right, so let's do that. Let's look at the traces on the computer. Ours by hand worked, but it's nice to really see them in action. So here, when we fix y, let's close that. When we fix y, you can see the parabolas we were getting as we trace it along. So they kind of go higher, they're at 0, and then on both sides, they start dropping again. There's kind of this high point at 0, and they're dropping on the other side. So there's the traces when you fix y, when you hold y constant. Now let's fix x. And so similar type paraboloid, these are opening down, whereas the y's were opening up. When I fix x, I get a parabola, opening down, and then there's a low point here. So in one direction, there's a high point, in the other direction, there's a low point. If you've ever done any hiking in mountain country, then you've seen places like this before out in the mountains. Kind of fun. All right, and then let's scroll down and let's fix the z's, and we're going to be able to see those hyperbolas playing here. So when we scroll up, we've got negative z's, and then all of a sudden there's that point. Remember where we saw z equals -1, the hyperbolas open in the y direction, and then when we go a little higher, they switch, and now they open in the x direction. And we saw that by hand, and you can see that on the computer as well. All right, well, great job. You made it through 10.6. Thanks for your patience. And this is the last section where we won't do any calculus. I don't know if you've noticed, but 10.1 all the way through 10.6 in Calc 3 has involved no calculus. All that changes next time. Take care.